Compute an ANOVA table using Randomized Complete Block Design for 6 varieties of maize in 3 blocks.
The randomized complete block design is kind of similar to the complete randomized design. So we are going to be using the same step. However, some calculation is going to be different because of the presence of block. We are going to calculate some things which is not included in complete randomized design. Trust me, after watching this video, you'll be able to solve question on randomized complete block design. Now let us proceed to solve the question. As you can see, I have variety 1, variety 2, variety 3, 4, 5, and 6. These varieties are also known as treatments. You understand? They are also called treatment. And to solve this question, the first step is to take the summation of each treatment. That is the row total. I'm going to have another column in this place, which I will sum each of these treatments. So I'm also going to take the column total, which is the summation of each block. Are you getting it? So I'm going to have row total. Let me call this RT, row total, and let me call this place column total, CT. Let me call this row total and the column total. Now, let's proceed. For variety 1, I'm going to have the row total for variety 1 will be 2.5 plus 2.7 plus 2.9. That is 8.1. So for treatment 2, which is variety 2, that will be 3.8 plus 3.9 plus 4.2, that is 11.9. 11.9. So for variety 3, that will be 5.8 plus 5.9 plus 5.7, that is 17.4. 17.4. So for variety 4, that is 3.9. For variety 5, that is 14.2. 14.2. And for variety 6, that is 3.3. So after taking the sum of each treatment, let us take the sum of each block, that is the column total. So for this, I'm going to have the addition of this. So this is 18.8. And for block 2, that is 19.8. And for the third block, that is 20.2. So after taking the row total and the column total, the next step is to check whether the row total, the summation of the values that you got in the row total is equal to the summation of the value that you got in the column total. And when I calculate mine, I got 58.8. Having gotten the row total and the column total, the next step is to calculate the correction factor. The correction factor, let me represent it as CR, is given by this formula. Summation x squared all over n. Summation x is the summation of all our observation. And if you check, we have already have the summation of all of our observation as 58.8. So I'm going to have 58.8 squared all over n. N is the total numbers of observation. And if you check, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The value of n is 18. That is the total numbers of observation. So 58.8 squared is 3,457.4 all over 18. When I divide this, I got 192.08. So the value of our correction factor is 192.08. After getting the correction factor, the next step is to calculate the total sum of squared. The total sum of squared, TSS, is given by this formula. Sum of the square of each observation. Sum of square of each observation. Let me put it observation minus the correction factor. The sum of the square of each observation minus the correction factor. So the total sum of squared is equals to 2.5 squared plus 2.7 squared plus 2.9 squared plus 3.8 squared plus 3.9 squared plus 4.2 squared So when I sum this squared, I got total sum of squared is equals to 246.22 minus the correction factor is 192.8. So minus the correction factor 192.08. So the total sum of squared is equals to 54.14. So total sum of squared is equals to 54.14. 54.14. After getting the total sum of squared, the next step is to calculate the treatment sum of squared. From this question, the treatment sum of squared is also known as the variety sum of squared because the treatment that we are dealing with in this question is varieties. So I'm going to have variety sum of squared, and the formula is given by this: summation vi squared all over n minus the correction factor. Summation vi squared is the summation of the square of the total of each varieties. And if you look at this, we have already summed the total of each varieties. So, and n is the total numbers of time each variety repeats themselves minus the correction factor that we have already gotten as 192.08. So, the variety sum of squared, VSS, is equals to summation vi squared. Let's start with variety 1. The sum of variety 1 is 8.1. So, I'm going to have 8.1 squared plus the sum of variety 2 is 11.9 plus 11.9 squared plus 17.4 squared plus 3.9 squared plus 14.2 squared plus 3.3 squared all over the numbers of time each variety repeats themselves. And if you look from this question, the variety repeats themselves in 3 times. That is 1, 2, 3. Each variety repeats themselves in 3 times. So I'm going to have all over 3 minus the correction factor. Don't forget that the correction factor is 192.08. 192.08. When I sum the square of each varieties, I got variety sum of squared is equals to 737.72 all over 3 minus the correction factor, that is 192.08. So the variety sum of squared is equals to 245.91 minus 192.08. So the variety sum of squared is equals to 53.83. So I'm going to have in this place the variety sum of squared is equals to 53.83. After calculating the variety sum of squared, the next step is to calculate the block sum of squared. Don't forget that we are dealing with randomized complete block design, RCBD. That is the major difference between CRD, complete randomized design, and the randomized complete block design that we are dealing with right now. Probably if you don't know how to solve ANOVA using complete randomized design, you can proceed back to the channel and watch the video. I've already solved it step by step. Now let us proceed. The block sum of squared is given by this formula. Block sum of squared is equals to summation of bi squared all over n minus the correction factor, where summation bi squared is the sum of the square of each block. As you can see in this place, we have block 1, block 2, block 3, and the sum of block 1 is 18.8. So therefore, the block sum of squared is equals to 18.8 squared plus the sum of block 2 is 19.8. So I'm going to have 19.8 squared plus the sum of block 3 is 20.2. So I'm going to have 20.2 squared all over n. N is the numbers of time that each block repeat themselves. For this, I have 1, 2, 3, 4, 5, 6. So that will be all over 6 minus the correction factor. The correction factor is 192.08. 192.08. Block sum of squared is equals to 192.08 0.52 all over 6 minus 192.08. So the block sum of squared is equals to 192.25. When I divide this, I got 192.25 minus 192.08. 192.25 minus 192.08. Block sum of squared is equals to 0.17. So after getting the block sum of squared, the block sum of squared is equals to 0.17. After calculating the block sum of squared, the next step is to calculate the error sum of squared. The error sum of squared is getting by subtracting the summation of variety sum of squared and block sum of squared from total sum of squared. So I'm going to have the error sum of squared is equals to the total sum of squared minus the sum of variety sum of squared and block sum of squared. So the error sum of squared, the total sum of squared is 54.14. 54.14 minus 53.83. That is the variety sum of squared. Then for the block I got 0.17. So if you add this together, you are going to get 54.14 minus 54. So the error sum of squared is equals to 0.14. So we have gotten the error sum of squared as 0.14. Okay, now we have gotten the total sum of squared, variety sum of squared, block sum of squared, and the error sum of squared. The next step is to compute our ANOVA table. A typical ANOVA table looks like this. We have the source of variation, the degree of freedom, the sum of squared, the mean squared, the F calculated, and the F tabulated at 5% and 1% respectively. Now let us start by filling the source of variation column. I want you to note that on every ANOVA table there is always a total source of variation. So I'm going to have the first source of variation as total. Then based on the calculated parameters or the given parameters in the question, we are going to fill the others. From our calculated parameters, we have the variety, block, and error. So I'm going to put variety, block, and error. Don't forget that variety is also the same thing as treatment. You can also represent it as treatment. Okay, now let's proceed. We have already calculated the total sum of squared. So the sum of squared for total, the value of these cells will be 54.14. So I'm going to have here 54.14. The treatment sum of squared is 53.83. So I'm going to have here 53.83. Don't forget that the variety is also the same thing as treatment. Okay. The block sum of squared is 0.17. So I'm going to have 0.17 in this place. And the error sum of squared is 0.14. So I'm going to have 0.14 in this place. Now let us proceed to calculate the degree of freedom for the total, variety, block, and error. To get the degree of freedom, don't forget that the formula of degree of freedom is given by this. Degree of freedom is equals to n minus 1. Now to get the total degree of freedom, the total degree of freedom is equals to the total numbers of observation minus 1. If you check from this table, the total numbers of observation is 18. So I'm going to have 18 minus 1. The total degree of freedom, the degree of freedom for total is 17. So the value of this cell is 17. Now, let us calculate the variety degree of freedom. The variety degree of freedom is gotten by subtracting the total numbers of variety minus 1. So, variety degree of freedom is equals to, don't forget that the total numbers of variety that we have here is 6. So the variety degree of freedom is equals to 6 minus 1. So 6 minus 1 is 5. So the value of these cells is 5. Now, how do we get the block degree of freedom? Don't forget that the total number of blocks that we have here is 3. 1, 2, 3. That is the total numbers of blocks that we have on this table. So block degree of freedom is equals to 3 minus 1 is equals to 2. So the value of these cells is 2. Now, to calculate the error degree of freedom, we are going to add the variety degree of freedom and the block degree of freedom together and subtract it from total degree of freedom. The error degree of freedom is equals to the total degree of freedom minus the sum of variety degree of freedom and block degree of freedom. So the total degree of freedom is 17. 17 minus 5 plus 2. So we're going to have 17 minus 7 is equals to 10. So the error degree of freedom is 10. So we have completed the column of degree of freedom. Now let us proceed to the column of mean squared. How do we get the mean square for total? Don't forget that mean square is given by this formula. Mean squared, let me represent it as ms is equals to the sum of squared all over the degree of freedom. Total mean squared is equals to the total sum of squared all over the total degree of freedom. Don't forget that the total sum of squared is 54.14. So I'm going to have 54.14 all over the total degree of freedom is 17. Is 3.18. So the value of the total mean square for this cell is 3.18. Okay, let us get the variety mean squared, which is also the same thing as treatment mean squared. The variety mean squared is equals to variety sum of squared all over the variety degree of freedom. And the variety sum of squared is 53.83. So I'm going to have 53.83 all over the variety degree of freedom is 5. So I'm going to have all over 5. 53.83 divided by 5. The answer is 11.77. So I'm going to have 11.77 in this place. So the value of these cells is 11.77. Okay, let us calculate the mean square of block. That is block mean square. Block mean squared is equals to the block sum of squared all over the degree of freedom of block. So the block sum of squared is 0.17. So I'm going to have 0.17 all over 2. The answer is 0.09. So the value of mean square for block is 0.09. Okay, let us calculate the mean square of error mean squared. Error mean squared, the error mean squared is equals to the error sum of squared all over the error degree of freedom. And the error sum of squared is 0.14. 0.14 all over the error degree of freedom is 10. 0.14 all over 10. 0.14 divided by 10. The value is 0.014. So the value for this cell is 0.014. Don't forget that from the question, they are giving us that the F tabulated of variety at 5% is 3.33. So the value of these cells, variety, the value of this cell is 3.33. And F tabulated of variety at 1% is 5.64. So the value of these cells is 5.64. And F tabulated of block at 5% is 4.10. So the F tabulated for block at 1% is 4.10. And F tabulated of block at 1% is 7.68. So for this cell, I'm going to have 7.68. Now let us calculate the F calculated of variety and block, because we are only given the F tabulated of variety and block. So I'm only interested in F calculated of variety and block. Now, to get F calculated is given by this formula. F cal is equals to mean squared all over error mean squared. That is, mean square of the parameters that I want to get is F calculated all over error mean squared. Now let us calculate the F calculated of varieties. So I'm going to have F calculated for varieties, variety F cal is equals to variety mean squared all over error mean squared. So variety mean square is 11.77. 11.77 all over the error mean squared. Error mean squared is 0.014 all over 0.014. 11.77 divided by 0.014. The answer is 840.71. So this is 840.71. So the value of these cells is 840.71. So let us calculate the block F calculated for block. Block F calculated is equals to block mean squared all over the error mean squared. So the block mean squared is 0.09. So I'm going to have 0.09 all over the error mean squared. The error mean squared is 0.014. 0.014. The answer is 6.43. So the value of these cells is 6.43. So we have successfully computed the ANOVA table for this data. Thank you very much for watching the video. Please, I would like you to subscribe to my channel if you have not done so.